Welcome back. All right, so now we're going to figure out the type of congruence that exists between triangle AQR. All right, so AQR, that's the larger one, right? The overlapping ones, and triangle CQR. Right, so this one just a teeny bit longer than the other ones, and I think maybe we'll do this one. We'll write up a proof for this one, right? Right. So, but actually, we only have 3 more slides left before the next video. There's a lot of blue here. I'm going to switch colors, and I'm going to draw the triangle in green. All right. So we've got this triangle here. All right, and so that's triangle AQR. And then we have the other overlapping. I'll draw that one in red. So always make sure you know what triangles you're proving congruent. You just can't say, you know, I like these ones. No, make sure you're proving the right pair of triangles congruent. Right? So you can see we have the 2 overlapping. We have 2 smaller triangles here. We have another triangle there. Right, that's a lot of triangles, right? So we have to make sure we choose the right ones. And not all of them may be congruent. All right, so this one is C, Q, and R. All right, so now let's first start with our given information. All right, so I think I'll stick with writing in red here since it's in my hand. All right, so we have BQ is congruent to BR, and angle CQA is congruent to angle ARC. By the way, if you run out of room, you can always just add a little sticky note or do this on another sheet of paper. All right, so the reason for that is given. Start with your given on these, right? All right, so we have BQ, which is BQ. All right, look at I'm trying to. So look at that information we're given. All right, so we want the larger triangles. That's why I said this one. This one was a little bit longer. And I'll look at BQ, and BQ is not a side in either triangle. BQ goes from here to here. But we're not proving the smaller triangles congruent. We're proving the overlapping ones. It tells us. All right, so we're going to need to mark that information on the diagram we're given. So BQ is congruent to BR. How can that help us? And we're given that angle CQA. So CQA, which is this angle here, also not in our triangle, is congruent to angle ARC, this angle here. Well, that's not very helpful, is it? None of those things are in the triangles we're trying to prove congruent. We got nothing to mark. Right. Well, maybe we can use some of that given information to find some information that would help us. I think, though, maybe we should start, we're going to use that given information, right, because they wouldn't give it to us if it wasn't helpful. Right? But notice this here. Mark the diagram with the given information. Be careful, you don't always use all the information. Right, so sometimes we might not use something. But if it's given to us, it might be helpful. So we better mark it in our diagram. All right, so now there is something else, though, we could say about our triangles that is in our triangles. Look carefully at the points, AQR and CQR. What do you see they have in common? We know that they both have segment QR. Right? I'm going to mark it in the original diagram. So look at QR. Notice that the 2 triangles overlap at QR. They share that point, that segment, that side. That's a shared side. Right? So I do know that QR is congruent to QR using the reflexive property. So even though it doesn't relate at all to our givens, let's write that one down because that will make us feel good that we at least got something in our triangles that we know is congruent. All right, so now we either need two more sides if we want side, side, side. That might be kind of hard. Right? I don't know how many more sides we can get congruent here. That might be tricky. We can get a side and an angle. Right? If it's the angle that's between our side, other side. Or maybe we can get two angles. Right? Let's see which one is congruent. Which one is we could possibly get. If we can't get those things, then we can't prove our triangle is congruent. So it's our option D here. Now, there's something that you're going to be learning in the next series of lessons about triangle theorems that you don't yet know. Right? But I do like to do the congruence because it relates directly to transformations first, and then the triangle theorems second. Right? Because that will give us some additional information, and I can always reference something in advance. So I'm going to reference something from triangle theorems. And this is what I'm going to reference. I'm going to reference the fact that because these two sides are congruent, these two angles have to be congruent as well. I'm going to actually write in a different color so it stands out. I'm going to switch to green. All right, so since those sides are congruent, the angles opposite those sides have to be congruent as well. And this is something you'll learn when we look at isosceles triangles in more detail. Right? And so I know for a fact that angle, I can call it B or I can call it C. I'm going to use B. Right? So angle BQR, oh, I guess I should stay in red. It looks kind of weird. Angle BQR is congruent to angle BRQ. And the reason that's true is something called base angle theorem. And I'll put it over here because otherwise I'll get too busy up there. So base angle theorem is for isosceles triangles. It's also, by the way, for isosceles trapezoids, but we'll just work with isosceles triangles because that's what we're working with. So base angle theorem says that angles opposite congruent sides in a triangle, so it's a single triangle, are congruent. It does work the other way too. If I knew the two angles were congruent, the sides opposite them would be congruent. Right? And we know that in an isosceles triangle, we're going to have two sides congruent, and we're also going to have two angles, and those angles are going to be the ones opposite those two sides. They're going to be congruent as well. All right, so now we've got another piece of information thanks to BQ being congruent to BR. It didn't seem like that was going to be helpful, but they gave us an isosceles triangle. Let's see, is that in our picture here? Can we mark something? Let's see. So we have angle BQR. Well, you know what angle BQR is? It's the exact same angle, so maybe I should change its name. So while BQR uses the sides in the isosceles triangle, I don't have to use B, I could use C, right? It's going to be the same angle. So what if I called it angle CQR? That might help us out because we might figure out whether it's in our triangle. And what if I called it, I don't have to use A, I could use A up here instead and just call it angle ARQ, same angle, angle ARQ. Either way, it's the angles that we marked. But if I call it CQR, I think it makes it easier to figure out. It's this angle right there. This angle right there, CQR. And ARQ is this angle here. And now we got an angle congruent. So either we got to get angle Q congruent to angle R, or we got to get AR congruent to QR. And I'm going to tell you, I got nothing, absolutely nothing to get AQ congruent to CR. I don't have enough information. There's just no way I can do it. But can we get angle A congruent to angle C? Let's see. Right, so we're going to use all of our knowledge of geometry definitions and properties for this one. All right, so notice that angle Q here is formed by these two angles. So the angle in my triangle that I need, angle AQR. It sounds like a mouthful. Angle AQR is just equal to angle AQC plus angle CQR. So I'm adding up the two little angles, right? Well, I'll label them, right? We'll call this angle 1 and angle 2, right? And on the other side, maybe I should choose a new color. We got a lot of red in there. Angle 1 and angle 2. Okay? Let's label this angle 3 and angle 4. All right? So I'm just adding up angle 1 and angle 2. Angle AQR, or angle AQC and angle CQR. It's a lot easier to call them angle 1 and angle 2. All right? So if we add the two little angles up, we get the big angle. Notice that big angle is angle Q in our triangle. We can also add up the other two angles, the angle 3 and angle 4, right? And actually, if you prefer, if you're tired of looking at all these letters, it would fit in better if I just called it angle 1 and angle 2. So we'll do that. We've labeled it angle 1 and angle 2, so we don't have to write as much. So angle 1 plus angle 2, that's going to equal our big angle there in the our triangle over here. AQR, right? So this angle here, right? That's angle AQR. And I'm going to take that out, though, because we haven't proven anything about congruence yet. So angle 1 plus angle 2 equals angle AQR. On the other side, angle 3 plus angle 4 is equal to CRQ. And how do we know that to be true? That's called angle addition postulate. We just added two little angles to equal the big angle, that's all. Nothing really fancy about that. Right, so I'm going to run out of space here. I should have written small. But did I? No. I knew I needed to write small, but I didn't. All right, so now what you might think, oh, why was that important? Well, we got our angles that we needed in the game, right? We got angle AQR and we got angle CQR. Well, they're in the game, but we don't know they're congruent. But we do know some other things are congruent. So, for instance, we know angle 2 is congruent to angle 4. So what if I did this, right? So what if we did, and we also know, we know angle 2 is congruent to angle 4. We also know that angle 1 is congruent to angle 3, right? That was what we were given. So what if I rewrite it like this, right? Angle 3 plus angle 4 is equal to AQR. What did we do there? Right, so there was a 1 and a 2. But we made them a 3 and a 4. Well, since 1 is congruent to 3, right, that has the 1 congruence marking. And, oh, speaking of that, I better be careful not to mark anything with the wrong number of marks. No, that was okay. That one actually had 2. So I do need to fix that. If you notice in the diagram above, I just digressed for a second there. So technically it's two different diagrams, but let's keep it the same. Those were the angles with, those angles had two congruence marks in the big picture. So I better make sure I don't change that. All right, back to this problem. So if I replace angle 1 with angle 3 and angle 2 with angle 4, I'm just making a substitution. I'm substituting one congruent thing for another. So now this is substitution. And you know, I have all this space. Well, I don't know if I can call all this space, but I have space over here. And these triangles, they're really crowding up my steps. So I'm going to move this over just a bit so that we can finish our problem. And you all can just watch me move letters. Oops, this goes with this triangle here. And get rid of the box now. Oh, we're so close. Come on. Whoop. Move. Move. All right. That was your last chance. I was going to leave you there. All right, let's move. Of course, one letter moves. How about the whole triangle? All right, there's the triangle. You know, if I pause for just a second, it decides, oh, you want me to highlight that, right? You want me to do something with that. No, I want you to move. That's what I want you to do. All right, so let's just put our congruence marks in there. There we go. There we go. Move over and be that way. There we go. Now I have some space. All right, so step 5 here. Oh, and see, you move over here. So step 5, all we did is we replaced one thing for something congruent to it. All right, and so that's just substitution. There, finally, I can write the rest of my word. Well, now look at, these were both congruent to angle 3 and angle 4. If they're both congruent to angle 3 and angle 4, they must be congruent to one another. So that means that angle CRQ is congruent to angle AQR. That is the transitive property. Two things are equal to the same thing. They're equal to one another. That's different than substitution. Substitution is just, this is equal to this. I'm just going to replace this with that. Whereas transitive property, it's like it needs a middleman. Right? They're not equal to each other. They're equal to the same thing. Let me make that a little bit neater. So 6 was transitive property. Let's see if I can make it so you can read it. There we go. And actually, we're just about done now. So now we can mark CRQ is this one here. We'll give that one 3 congruence marks since nobody's got 3 yet. And angle AQR is over here. Which one of our triangle congruence postulates is it? Why, it's angle side angle. So I'm actually going to write my last step over here. Right? And so we'll do the reason first. Angle side angle, that's the reason why triangle AQR is congruent to triangle CRQ. There we go. So this is as tricky as it gets, I think. Let's see if we were right. Woohoo! We were right. Angle side angle. All right, so this is as complicated as it gets. So when it's this complicated, you want to draw it separately, right? And you want to work through a proof to get to which of your congruence postulates works, right? Now we've done a tricky one. Maybe the next one's an easier one. I've got 2 more for us. I promise, even if it's not super easy, that one was our hardest one. This one is super easy. Super, super easy. And that's already marked for us and they don't overlap. What type of congruence exists between the 2 triangles? There's a hint. At the intersection of 2 lines, you always have, and so if we have intersection of 2 lines, we always have blank angles. Well, there's lots of things I guess I could fill a blank in there. I could fill it in with 4 angles. I do have 4 angles there, 1, 2, 3, 4. That's not very helpful. But 2 of these angles that happen to be in our triangle are special angles. we have vertical angles. So anytime you have intersecting lines, you have vertical angles. And we know that vertical angles are always congruent. Which means this angle is congruent to this angle. And what do we have? We have side, angle, side. Two sides, the angles between them, right? If we follow the two sides, they intersect right there where the angles are. So, side, angle, side. Side, an angle, and a side. And see, side, angle, whoop. There we go, side, angle, side. All right, so, we should write that. Triangle SAN is congruent, so if it's SAN, it's got to be DAT. Right, this one is reversed. There we go. And the last one for angle, side, angle, and with appearances by some of its friends, side, 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 and side, angle, side, is this one right here. Oh, I don't like seeing spinning ball of death. Just change my page. Ah, there we go. Phew. What type of congruence exists between the two triangles? All right, mark what you're given. All right, so we are given PA is congruent to MA. We are given that angle P is congruent to angle M. That's our given. Is there anything else we know? I hope you see you've got vertical angles, right? And we know that vertical angles are always congruent. And so this section dealt mostly with angle, side, angle. And so a good way to end this podcast is an angle, side, angle problem. I'm going to just write that just a little bit neater. That's pretty sloppy looking. Right, so we had the two angles. These ones were the vertical angles. We know they had to be congruent. And then we were given that PA is congruent to MA. And so angle, side, angle makes triangle PCA congruent to triangle MSA. Okay? So hopefully you filled in your notes along with me, and now you know a lot about, I didn't say anything under there, but it is angle, side, angle. Angle, side, angle, and its friends, side, 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 and side, angle, side. In the next series of podcasts, we will look at a new triangle congruence postulate. Bye for now.